All right, here's section 1.5, segments and their measures. So the points on a line can be matched 1-to-1 with real numbers. The real numbers that correspond to a point is called the coordinate of the point. In the diagram, x sub 1 and x sub 2 are coordinates and read as x sub 1 and x sub 2. So I have a line. Oops, hold on. Why is this not showing? I have a line. And then I have points A and B. Now, that's the name of the points. But I could say this value is
1.
And this value is
3.
So these are the coordinates. But the name is A. It's just like your name is Eli, but your coordinate is you are 3 years old. Yep. All right. The distance between A and B is just written as the capital letters. Notice there's no lines above. There's no segments. And the distance is the absolute value of the difference between points A and B. Because we want distance to be positive.
No, these are the train tracks.
Those are the train tracks. Nice job. So, and train tracks are parallel. They never touch. So the absolute value of the difference between A and B. So if I want this length, it shouldn't matter where I start. I just want to know how far apart they are. So by doing the absolute value, this is going to make it positive. This makes my distance positive by having the absolute value. All right, let's try a problem. Here I have a shark tooth and I have a ruler. So that measures how big it is.
Why is that a shark tooth?
Because it's a shark tooth, right? This is the root and this is the part you see. It's just like this part right here. This is the part you see. And then the root goes into the gum. All right. So we want the total length of the shark tooth. So what we can do is, let's see, I want to know at what measure are we at. So at A, I'm at 0. And then, okay, so if this whole thing is 1 inch, this right here is half. And half of a half is a fourth. And half of a fourth is 1/8. So this goes by 1/8. So 1/8, 1/4, 3/8, a half, 5/8, 3/4. This is, okay, 6/8, so this is 7/8, and then 1. So I'm going by eighths because 2/8 is the same as 1/4. So this is at 0, this is at 7/8, and then over here this is 2. This is 2.5, so this would be 2 and 1/4. So first thing we want is the total length of the shark tooth. So if we're going from 0 to 2 and 1/4, what is the length, right? So we have to take the absolute value of x2 minus x1. So my x2 is 2 and 1/4, and I'm subtracting x1, which is 0. And the absolute value, this is just going to be 2 and 1/4 inch. What?
Yeah,
2 and 1/4. Exactly. Then we want the length of the exposed part. So this exposed part is just this distance, how much tooth is showing. So we can take, if I want the length from B to C, that's the length of the exposed. So I'm going to take x2 minus x1. So 2 and 1/4 minus 7/8. All right, let's get going with the math. So this is going to be the absolute value. So if I rewrite this is going to be 9/4 minus 7/8. We have to have them make the same denominator. So I multiply by 2 over 2. All right, rewrite this as 18
this direction Venus is a big
4.
rectangle.
Which thing is?
This small
one. The thing that's recording? Yeah, it's a big rectangle.
It's a big rectangle.
All right, so 18 minus 7 is going to be 11. Oops, I forgot to multiply this. So I have absolute value of 11 over 8 is just going to be 11 over 8. And if we rewrite this is 1 and 3/8 inch. Okay, awesome. So this is betweenness. When there's 3 points on a line, one of them is between the other two. So if you, Kinsley, and I all stand in a line, right? Maybe this is me. Now let's see, you want blue, so this is going to be you, and then Kinsley. So Kinsley's right here. Guess what? You're going to be between us. So if I draw a line with 3 points, right? Let's say H is for Holly, E is for Eli, and K is for Kinsley. Notice this point E, you, Eli, you're between us. So we want to sketch a line with 3 points, A, B, and C, where B is between points A and C. So I'm going to, here's A. Here's C. Can you point, where will B? Where should I draw my B? It has to be between A and C. So where should I put it? Do you know? Will you point for me? On this side? So remember, it has to be between. It has to be in between the two. So B has to be between. I don't want to put it over here because then C is between, but I want B between. All right, so segment 5, the segment addition postulate. If B is between A and C, then the whole thing, A to C, is just the sum of its parts. So let's show this. This is point A, this is B, this is C.
No one.
Circular. All right, so B is between them, right? So if I want, AC, the whole length is going to be equal to AB. So this part plus BC. Oops, I didn't pick the right colors. Okay, so this portion, which is BC. So you see how this blue rectangle is the same length as if I would add green and yellow together? It's like a long Duplo block is the same as the two small Duplo blocks put together because they're the same length. So an example is, so ready, you have this like Duplo sheet. So remember how you like make a little tablet out of it? All right, so this length right here, I think it's like 4, I think it looks like this. So this length is going to be the same as one of your green Duplos right here plus the yellow Duplo right here. They're both, right? These two things are the same length if you add them together as the whole sheet across. So this is the segment addition postulate. The parts add to equal the whole. All right, so we can flip it on its head. So if we have length AC, so this is AC, and this is going to be equal to, let's see, A to B plus B to C. So I'm going to use a little highlighter, right? Highlighter action to help us out. So if the whole length AC is equal to AB plus BC, then we can say point B is between A and C. Just 3 collinear points. Remember what collinear means? They're on the same line. They're on the same line. So that's crossing, intersection, but 3 collinear means they're on the same line. So I draw a line with arrows at the end to say it goes on forever. And K is between J and L. So can you show me where should I put K? It has to be between, in the middle. So where's the middle? Exactly, right here. Good job. So this is K. And then we're going to write the segment addition postulate. So what this means is the whole length, J to L, is going to equal JK plus KL. So I have the whole length.
The letter Dad starts with is D, Dad.
D for dad. Nice job. I should use D in my example. So the whole length, JL, you see in the blue, is going to equal JK, this segment, plus KL, the yellow. Right? A long Duplo block is the same as if I put 2 small Duplo blocks together next to each other. So the parts equal the whole.
So I have Duplo blocks.
You do. Let's do the next one. S is between T and U. You want to help me? Eli, where does S belong? Will you show me? So right here in the middle. Yeah. S is between T and U. So this means T to U is equal to TS plus SU. So I'm going to show this. So the whole thing, T to U is equal to TS, so this first portion, plus the second S to U. Use the diagram to find E to F. So let's see, the whole thing, DF, is going to equal DE plus EF. So I have 16 is equal to 10 plus EF. So the whole is equal to the sum of its parts. So both of those together. So that means 10 plus this portion have to equal 16. So that means 6 is equal to EF. All right, find the length, AC. So the whole length is AC. This is going to equal AB plus BC. So AC, A to B is 14, B to C is 6. That means the length is going to be 20. Find ST. So together, the whole distance SR is equal to 23. And so the whole is equal to the sum of its parts. So ST plus TR. So ST plus 15, if I subtract 15 on both sides, I get 8 is equal to ST. Solve for X. So here we go. Okay. So, okay. So, I want AC is equal to AB plus BC. So if I say the total is X plus 13, this is going to be AB, which is X plus 2, plus 11. So I have X plus 13 equals X plus 13. So what you get is 0 equals 0, so which means infinitely many solutions. Not a great problem. We're going to skip part B because it doesn't make sense. All right, algebra review. How do we get these variables by themselves? So divide by 3. Here, multiply by 4, so that crosses out and we get 8. Divide by -5, so we get n is -6. Multiply by -7, we get 42 is equal to v. Alright, so multiply by 2 on both sides. So 2 times a half goes away, and then this is going to be 24. Alright, divide both sides by 10, and we get 4.5. So the little trick when you're dividing by 10 is you move the decimal place over by 1. Now, imagine we were dividing by 100. You'd move the decimal place over by 2, and that's the quick trick. Alright, last part. This is going to be part of the 1.6 lesson since that's what we did in class.